what I would like to do to start off with, this was a question that we looked at class yesterday. We were going through class yesterday, and it caused some confusion, particularly the negative pi part and our negative rotations, and how do we justify that we get some negative solutions. So I went back, had a chat to some other teachers, and tried to come up with a simpler way of coming about and how we would get to answers here. And I think for me, one way to think about it is we know that if these are just a set of axes to begin with, we know our sine wave all right, that was pretty good, just quietly off the top of my head. All right, we know that our sine wave, because of its nature, it repeats itself, right? Same thing when we talk about our unit circle. You know how we talk about doing laps of our unit circle. All we are doing is the exact same solution. We're finding the exact same number, but when you first find a value in here somewhere, the next time you come around to that value, it's 360 degrees later. So you're using the exact same angle, but you're just adding 360 degrees to it, or you're adding 2 pi. When you come around for the third lap in the unit circle, you're adding 720, or then you're adding 4 pi, and we just continue on like that. So our solutions, they follow a pattern. You just keep looping through. Once you've found what you need to do in the first 360 degrees, they're just looped through patterns of them. Is everyone, that's a comfortable idea? We've seen that a lot, yeah, that looping through pattern. One way I was talking about, and what I want to try and do is I don't want to kind of find a band-aid solution that just goes one thing fixes all. I want to try and do something that's comfortable, that we can repeat that process without going, oh, but now in this situation, because the domain's changed, we've got to do this, or because there's a change in period or there's a phase shift, we've now got to do this. I want to find something that we can think of that will apply to everything, and we can move through that logically. So how I want to tackle that is we've been asked to solve, well, sine of x minus pi and 4 equals 1 on root 2 for negative pi and pi. So we've got some negative rotations in there. So one thing I'm going to do, if we're looking at this, I'm just going to say, well, let theta equal x minus pi and 4. So really, I just want to think about, to start off with, when does sine theta equal 1 on root 2? Does that make sense? Get away that ugly junk in the middle and just go, well, because that's something we're comfortable with. That's something we're a bit more familiar with. There's no periods happening there. There's no shifting of phase shifting happening there. That's something that we're comfortable with. One thing that we need to recognize as well is that these are the positive solutions. All right, so now we've got to start thinking in this way, that shape form again from our basic one. They're our positive solutions. Yes, there is a square root in there, but you haven't had to be the one to take the square root. You haven't physically found the square root of something. Because you haven't had to do that process, you don't need to think about the positive or the negative situations. You haven't physically applied the square root. We've done it for you. And by us doing the square root and not putting plus minus there and only leaving it as the positive version, we're saying we only want you to consider the positive versions of this square root. Does that make sense? Just because there's a square root symbol there doesn't mean it needs to be plus minus. We've given you the square root, and we've given you what sign of the square root to take. We've told you you want to take the positive version here. So what we're looking for are, well, when are all of our when is sine positive solutions? So just to the right, I'm going to think about that's that, and now or stops to central. And this is going to be the last time I think about all stops to central. Does that make sense? And when is sine positive? It's positive in the first 2 quadrants. So I only want solutions to theta in the first 2 quadrants, right? Which would be just theta, and it's going to be 180 minus theta. Is that okay? Cool. So that's the last time we're going to think about all stops to central. So we know that theta is going to be 1 on root 2. Hopefully we recognise that's an exact ratio. So, and I don't know why I've written 180s over here. That should be pi. Right? So because it's our exact ratio, we know that 1 on root 2, that's 45 degrees, and 45 degrees is going to be pi on 4. Cool, so we're going to think about pi on 4, and we're just going to move pi on 4. Is that cool so far? Haven't thought about our domain, haven't thought about anything else, just thought about sine theta. When does it equal 1 on root 2? Is that okay so far? Something we're comfortable with. Now, I'm going to think about the domain a little bit. Not a lot, just a little bit. Oh no, undo pi. And the only thing I'm going to think about the domain here is that I've got a negative rotation and I've got a positive rotation. So what I'm going to think about is I'm going to do one full lap in the negative direction, and I'm going to do one full lap in a positive direction. Is that okay? So let's start off with positive. So if I'm going in a positive direction, I'm going angles in this rotation order here. So we want theta, so we want pi on 4. And what do we want over here? That's going to be pi minus pi on 4, so that's going to become 3 pi on 4. When ignoring everything down the bottom, because that's not the quadrants we're looking for. We're only interested in quadrants 1 and 2. So we want pi on 4. I want 3 pi on 4. Now I'm going to think about going in my negative rotation, right? So I'm ignoring quadrant 4 because sine's negative there. Ignoring quadrant 3 because sine's negative there. I want what's happening up in quadrant 2. So in a negative rotation, going around, to get to the start of quadrant 2 down here, that's negative pi. And then I need to go a little bit further up, don't I? So pi, I'm going to think of that as pi plus, or I can think of it as negative pi minus theta. We could do that. Whatever one you wanted to think about. But it's negative pi, and then you've gone a little bit further. We've gone pi on 4 units further than pi. So what we've done is we've gone pi and then pi on 4 plus it, haven't we? That's what we've done. So that gives us 5 pi on 4, doesn't it? Is everyone comfortable that was 5 pi on 4 rotation? How that was we did that rotation in the negative way, so I'm going to go, that was then negative 5 pi on 4. Is that okay? That's a negative rotation of that much. So I'm going to put brackets around it and say that's got to be negative, because I did all of that rotation in a negative direction. And my final solution is going to be all the way around to here. So it's 360 except for whatever part of rotation I've done. So 360, so 2 pi minus how much rotation we did, which was pi on 4. And it's going to be negative lots of that. So that's going to become 7 pi, negative 7 pi on 4. Yes, no, maybe? Yes. Negative 7 pi over 4. So they're my solutions. There's some of the solutions I'm looking for. That we've done, one lap in a positive direction, and we've done one lap in a negative direction because we had a negative rotation and we had a positive rotation. Is that okay? Cool? Right. So I'm just going to rewrite that. Now that I know what theta is, I know something more about theta as well, don't I? Now I'm going to bring into what we said theta was. We know that x minus pi on 4, that's what theta was. If that's what theta was, Theta we said is going to equal pi on 4. It's going to equal 3 pi on 4. It's going to equal minus 5 pi on 4. And it's going to equal minus 7 pi on 4. Remember, if we wanted to, we could still keep going. These solutions, they're just going to be cycles. So if we wanted to chuck a second lap around a unit circle, we just add 2 pi to that one. We add 2 pi to that one. We're going to take 2 pi away from these ones because that's that negative rotation. So we're going to go we want to go, but continue going in a further negative direction. That's why that's going to be taking away 2 pi. Is that okay? Adding for positive rotations, taking another one. And if we're going to chuck, another lap after that, well, then we're going to take, it would be like that one minus 2 pi. And then we're going to add 4 pi on that one would be the start of our third lap. Was that okay? Because it's just that same pattern, that same cycle over and over again. Cool. Now let's pause for a second and solve this algebraically. This algebra statement has 1, 2, 3, 4 different solutions. I forgot, we can say dot. Why have I included the dot, dot, dots? I forgot to mention this earlier. Why did you think I included the dot, dot, dots? Yeah, because it keeps going on. Remember, it's that cyclic, that sine wave goes on and on and on in that same pattern forever. So every lots of our period, we're going to get those solutions again. So each time you add 2 pi to it, you're going to get the next lot of solutions that happen to it. Right? I've only done this because let's see how that works. And if we need to add more, we can quite easily come back and add more because it's just repeat the pattern. Does that make sense? Cool. So if we add pi, so x will be equal to, if we add pi on 4 to everything. So if you add pi on 4 to every potential solution we have, that's going to get us just the value of x. Agreed? Well, so pi on 4 plus pi on 4, that becomes 2 pi on 4, which becomes pi on 2, just using our fraction skills. 3 pi on 4 plus pi on 4 becomes 4 pi on 4, it's a whole number, so it just becomes pi. Minus 5 pi on 4 plus pi on 4 becomes negative 4 pi on 4, so it becomes negative pi. And minus 7 pi on 4 plus pi on 4 becomes, I'm just going to leave that as an improper fraction, as a mixed, not a simplified, becomes minus 6 pi on 4 and dot, dot, dot. Yes? Does that make sense? Now that I'm kind of here, I'm now at this stage, now I've got x equals, now I've done the algebra part to it, I'm going to go back to my domain and I'm going to pick the solutions that match my domain. Pi on 2, that's inside my domain, I want that one, so we're going to stick with that. Pi is not in our domain, we can't be equal to pi, we've got to be less than pi, so I don't want that solution. Minus pi, in my domain, I want that. Negative 6 pi on 4, outside my domain, so I don't want that. So I ignore it. Because negative 6 pi on 4, that's a number greater than negative 1, isn't it? So it's got to be greater than negative pi. Notice how pi, it's the first solution that appears outside my domain on the right hand side. So that's how I know I don't need to go any further with my positive rotations because I've already found the first thing that doesn't work. This was the first solution outside my domain when I went in negative rotations. So that means I didn't need to go on any further because I've already found the first thing that didn't work. For argument's sake, if I got to a point and all these 4 solutions were inside my domain, I'd continue these dot, dot, dots in both directions until I got one solution that's not in my domain, until I arrive at the first solution that's not. Not that hard to add a couple of extra things at this stage because it's just the same pattern repeating. right? The next, we've got a solution at pi on 2, that's a genuine solution. Its next solution would happen 360 degrees later, 1 full period later, 2 pi later. So you add 2 pi to it. Pi on 2 plus 2 pi, that's 2 pi is 4 pi on 2, isn't it? So that becomes 4 pi on 2 plus, it's 5 pi on 2 if we add 2 pi to it. Do you agree? So that would be our one of our next dots that we could include. But we know we don't need to include it because we've already found something that's slightly above it that's not in outside. Does that make sense? Once you've found these and you're like, oh, actually all of them work, you just add the period. And that will give you your next lot of solutions. Does that make sense? And if they're still in the domain, well, you keep going because it's just that same pattern that you're doing over and over until you get something that doesn't work. And once you get the first thing that doesn't work, that's when you know you've got enough solutions. So therefore, x is equal to pi on 2 and negative pi. Was that okay? Cool. Hopefully that explained some stuff there.